Hello everyone. My name is Mary Hannah, and I'm currently a third-year anesthesia resident at the Ottawa Hospital in affiliation with the University of Ottawa. I've become interested in the effects of anesthetic gases on global warming. The information I've come across during my search has altered the way I deliver an anesthetic to patients. I want to share this information with you. My purpose today is to arm our specialty with knowledge about the environmental impact of inhaled anesthetics and provide 4 easy solutions that can be applied to your regular OR day while ensuring quality of care and patient safety. To understand what is global warming, I'm going to talk about the greenhouse effect. Our planet is enveloped by a thin biosphere which contains greenhouse gases. These greenhouse gases include carbon dioxide, nitrous oxide, methane, and water vapor. This layer is necessary to absorb the heat emitted by the sun and warm our planet to life-sustaining temperatures. Scientists agree that increasing amounts of greenhouse gas contribute to global warming. In fact, carbon dioxide levels have seen a 7% rate of rise over the last 16 years. That rate of rise in such a short time span is unprecedented. As these levels continue to rise, more heat is being absorbed, contributing to rise in temperatures. This rise in temperature leads to melting ice caps, increased precipitation, floods, droughts, and famines. Scientists agree that limiting global rise in temperature by 1.5 degrees Celsius per century may significantly decrease the impact of global warming. So far, our average rise in temperature is 2 degrees Celsius, and our century isn't even halfway complete. To understand how our specialty contributes to global warming, let's analyze the life cycle of inhaled anesthetics. Less than 5% of inhaled anesthetics are metabolized. Therefore, 95% of these gases are exhaled while still being active. To prevent the unmetabolized exhaled gases from anesthetizing the OR personnel, it has to be collected and discarded. That's done by the scavenger, which collects the gas via tubing into the hospital vacuum system, and then these gases are discarded into the atmosphere, and by doing that, we are harming the atmosphere by contributing to the greenhouse effect. Some may ask whether this is actually true. Scientists have actually measured the amount of inhaled anesthetics that is present in the atmosphere. They've demonstrated that these gases are present in significant amounts in the atmosphere, and that rate is rising. The environmental impact of modern inhaled anesthetics are dramatically different. Let's look at some data to support the variances between them and 4 solutions that can decrease the anesthesiologist's carbon footprint. Solution number 1. Avoid desflurane. To understand why, there is one important definition. By convention, the global warming potential of carbon dioxide is 1. Let's use the global warming potential to compare the commonly used inhaled anesthetics to carbon dioxide. Desflurane has a global warming potential of over 2,500. So desflurane will have a global warming impact that is 2,500 times stronger than carbon dioxide. And it is significantly stronger than the 3 other gases combined. To simplify the global warming potential, let's compare the usage of each inhaled anesthetic to the gas emitted from driving 1 hour in my car. I'm trying to get to St. Joseph's Oratory in Montreal from Parliament Hill in Ottawa. How much gas will be emitted from using each inhaled anesthetic for 1 hour? Using 2% sevoflurane at a fresh gas flow rate of 1 liter per minute for 1 hour has the same gas emission as driving 6.5 kilometers, so I'd barely leave Ottawa. using 1.2% isoflurane at a fresh gas flow rate of 1 liter per minute for 1 hour has the same gas emission as driving 14 kilometers. Using 60% nitrous oxide for 1 hour has the same gas emission as driving 95 kilometers, so that would take me a little over halfway to Montreal. Using 6% desflurane at a fresh gas flow rate of 1 liter per minute for 1 hour has the same gas emission as driving 320 kilometers. That gas emission is the equivalent to driving to Montreal and halfway back to Ottawa in 1 hour alone. So desflurane's greenhouse gas emission is not negligible. Some centers have completely removed desflurane from their stock. McNeil studied the carbon footprint from anesthetic gases, the energy consumption, and the supply chain from the following 3 operating rooms: Vancouver General Hospital in Canada, the University of Minnesota Medical Center in the USA, and the John Radcliffe Hospital in the UK. The greenhouse gas emission from anesthetic gases is 4% at the John Radcliffe Hospital and 63% at Vancouver General Hospital. And that is from the total greenhouse gas emission by the operating theaters. John Radcliffe Hospital's numbers are so low because they use sevoflurane and isoflurane instead. They made a significant impact by eliminating desflurane from their stock. Now that is something we can definitely learn from. Solution number 2. Limit the use of nitrous oxide. As previously seen, using 1 hour of nitrous oxide has the same greenhouse gas emission as driving 95 kilometers in a car. The atmospheric lifetime is another important factor while comparing the global warming impact of inhaled anesthetics. The atmospheric lifetime of nitrous oxide is over 100 years, so it absorbs energy for a lot longer than the 3 other agents. Nitrous oxide stays in our atmosphere not just in our lifetime, but also for the lifetime of our children and maybe even during the lifetime of our grandchildren. Nitrous oxide also has ozone depletion potential, making it even more harmful to our atmosphere. Solution number 3. Use low fresh gas flow rates. Increasing the fresh gas flow rate significantly increases the greenhouse gas emission. For example, using 6% desflurane at a fresh gas flow rate of 2 liters per minute releases 26 times more greenhouse gases per hour compared to using 6% desflurane at a fresh gas flow rate of 0.5 liters per minute. The same concept applies to the other inhaled anesthetics. Traditionally, however, sevoflurane has been used at a fresh gas flow rate of at least 2 liters per minute. That's because at low fresh gas flow rates, sevoflurane was found to produce a toxin called compound A in rats. If compound A accumulates in high concentration, it can become very nephrotoxic. Many studies, however, have disputed and refuted this, and many countries have eliminated the use of high flow rates for sevoflurane. Sevoflurane is safe to use at low fresh gas flow rates, and using low fresh gas flow rates is a reliable way to limit greenhouse gas emission from inhaled anesthetic. The 4th and final solution is to consider TIVA. I'm going to use life cycle studies to explain why TIVA is an environmentally friendlier option than inhaled anesthetics. Life cycle studies look at the environmental impact of an agent's production, transport, use, and disposal. Sherman compared the life cycles of desflurane, isoflurane, sevoflurane, nitrous oxide, and propofol. First, They studied the greenhouse gas emission from an inhaled anesthetic's production and exhaled waste. They also included the energy required to function desflurane's vaporizer. Desflurane accounted for the largest life cycle greenhouse gas emission, and most of the greenhouse gas was emitted during the agent's release. Adding nitrous oxide significantly increased the greenhouse gas emission. Then, they compared the greenhouse gas emission to propovol's production, usage at 100 micrograms per kilograms for 1 hour, and the wasted portion of the drug. They also included the energy used to function the syringe pump and the life cycles of two 60 milliliter syringes and the IV tubing. The environmental impact of propofol are exponentially smaller. In fact, the majority of propofol's greenhouse gas emission stem from the energy required to operate the syringe pump and not from the environmental release of the drug. Tiva proves to be another way to minimize greenhouse gas emissions. Here is a summary of the 4 solutions presented today, none of which would compromise patient care. Avoid desflurane, limit the use of nitrous oxide, use low fresh gas flow rates, and consider Tiva. I'm sure that there are many other ways that we can decrease our carbon footprint. As global citizens, it is our responsibility to find environmentally friendlier and more sustainable ways to practice medicine. I challenge you all to find other ways, either at work or at home, to decrease your carbon footprint. Because ultimately, we're only borrowing this earth. So let's give our children a better earth than we currently live in. Thank you all for listening to this presentation, and I really hope that you all develop the passion and interest that I did.